There are there are four, actually. There are 4 word problems. So we're going to do those. I promise you they're not hard. They just look different. The average walking speed, R, of a person living in a city of population P in thousands is modeled by the function R of P, that is the rate of walking when you live in a city with a certain population, is what you see right here, 0.37 times the ln, which is just log base e, times the ln of P plus 0.05. And so that's what we're going to be working with. Now it says where R is in feet per second. Okay, so the population of Wheeling is 40,000. Find the average walking speed of people living in Wheeling. Now we have to stop before we do anything else. The population is 40,000. But P is the population in thousands. So the thousands is already taken into account. So for that reason, P is going to equal 40. Okay? So not 40,000, but 40. So here's what we're going to be working with. Here's our formula. R of P equals 0.37 times the ln of P, which ought to have parentheses around it, plus 0.05. So I'm looking for R, the walking speed, when we have 40,000 people in our city. So 0.37 times the ln of 40 plus 0.05. All I have to do is go to the calculator and type that in. So, okay. 0.37 times, I don't really think I need to put a times there. I think it's understood, but what the heck? Here is the ln key right below the log key. So ln 40, close the parentheses, or the calculator won't understand what you're trying to say and will probably give you the wrong answer. Plus 0.05. So there we go. Quick look back. 0.37. Oh, look, you can actually see it. 0.37 times the ln of 40 plus 0.05. You can see the whole thing. Oh boy. Okay, enter. And this is what I get. That the walking speed is going to be 1.41. Well, I'm going to write it down. Copy it. That way, whoever reads the notes afterwards will see the calculation, which is important. right, so here we are, and I didn't put it in here, but I believe we round to 2 decimal places, and so the walking speed is going to be 1.41 with a 4 after it, but that 4 does not cause the 1 to go up to a 2 because it's too low. The number here has to be 5 or more to make that 1 go up to a 2. So the walking speed, when you have 40,000 people in your town or city, is 1.41 feet per second. And the feet per second is already in there. Okay, just pop up with a question if you have one. Now, this is the most famous use of logarithms. Okay, in this case, log base 10. The magnitude on the Richter scale of an earthquake. I've recently found out, I guess I was behind the times, we don't use the Richter scale anymore. Geologists don't use the Richter scale. I don't know what scale they do use, but they don't use the Richter scale. Okay, but we're learning about it anyway. When I grew up, when I was growing up, it was the Richter scale. I was fascinated by earthquakes. I still am, but I don't want to be in one. I was in a little one once in California. The room went up and down real fast. That was it. That was the totality of my earthquake. And that's good enough for me for the rest of my life. Yes. Just sharing. Okay. Magnitude R, that is the bigness of the earthquake. The magnitude R, measured on the Richter scale of an earthquake of intensity I, the strength is I, is defined as R equals the log, base 10. We don't write the little 10 when it's log base 10. We just write log. So we're going to have I over what we call I naught, where I naught is a minimum intensity used for comparison. So this is a baby earthquake. This is a little earthquake that maybe nobody can feel, or maybe they can just feel a little bit, and that's used as the minimum to compare everything else to. Okay. So here we have R, the magnitude, equals the log of the intensity divided by the basic intensity. Okay, now, if the intensity of the earthquake, so I, if the intensity of the earthquake was 10 raised to the 6.92 times the I sub 0 or I naught, what was the magnitude on the Richter scale? Well, let's find out. R equals the log of 10 to the 6.92 power times I naught. So it's this many times greater than the I naught basic baby earthquake over I naught. And the I naughts conveniently cancel out, leaving us with log of 10 to the 6.92 power. Now, after today, you're going to know a quick way to do this. You're going to be able to just look at it and say, oh, okay, R equals 6.92. But for now, let's put it in the calculator. Okay, I'm going to take the log of 10 raised to that power. So log 10 up arrow 6.92. If you have parentheses with that, you need to close the parentheses. As it is, I need to close this big parenthesis. So I hit the right arrow key to come down, and then I close my parenthesis, and I hit enter. 6.92. Okay, 6.92 is the magnitude. And you can feel that shaking. It's more than just a quick up and down, but it depends. Do you know it depends on the kind of soil you have? If we had a 6.92 magnitude earthquake here, with our soil, it would make it stronger, or the effects would be stronger than they are in California, where they have a completely different kind of soil, dirt. Okay, now why is that true? We might as well learn it right here. Why not? Here's a rule, an arithmetic rule. If you have a log to a base, and your argument is the same number raised to any power, let's call it C, then the answer is C. Because of things you haven't learned yet. So I'm not going to tell you because you'll see why in just a few minutes. But this is something to remember. Log base 3 of 9, well, that would be log base 3 of 3 to the second power, right? That would be 2. The answer is 2. I don't even need to stop and look in my calculator. I love cool rules. All right, this is one that almost everybody misses. But you don't have to. I'm going to show you how to do it. Look at that ugly looking thing. Ew. Well, if you're a nursing major, you're going to be dealing with logarithms to the extent that you deal with pH, the pH of the blood, the balance of the acid and the base in a base is a certain kind of chemical, and you know what that is if you've had biology. Okay, but the acid-base balance in your blood is called the pH. So the pH of fruit juice is 3.6. Find the hydronium ion concentration, OMG. Not to worry. Find the hydronium ion concentration, this thing, of the juice, and use this formula. Namely that the pH equals negative log bracket H sub 3, 0 plus. That means it lost an ion. Well, it lost an electron, so now it's an ion. And if that means something to you, that's good. If not, doesn't have anything to do with the math problem. What we're going to be doing is we're going to be working on this, and we're going to end up with this answer. And there'll be a number there. Now, why not get rid of that scary looking thing? In all seriousness. This is scary looking. Let it equal X. That's not anywhere near as scary looking. So 3.6, which is the pH of the orange juice, or the fruit juice it says, is negative log X. You can work on that. We did this yesterday. We're going to do it again. First, there's the number -1 in front of log base X. I mean, log X. This is log base 10 of X. We don't write the 10 when you have a base 10. And we talked about that yesterday. First thing I'm going to do is get rid of that -1. I'm going to divide it out. Divide both sides by the -1. That just makes it easier. Okay, so cancel, cancel. And we'll have -3.6 equals log X. Now we can do this. We did it yesterday. Log base 10 of X equals -3.6. How do you solve that? You go to the exact equivalent exponential function, which is you take the base. This is the power. So that what you get, an equivalent expression to this, is X equals 10 to the -3.6. Now all we have to do is calculate -3.6. But when you read this, use scientific notation. Okay, you don't know what scientific notation is if you've never had a science class. So your calculator will do you a favor, and you can reset it later. Go to mode. Click. Here's the setting for scientific notation. Click. Enter. Your calculator is now set up to use scientific notation. So, here we go. 10 raised to the -3.6 power in scientific notation is this. Isn't that ugly? Don't panic. Don't panic. Now, the instructions say, here's the answer. The instructions say use scientific notation, use the multiplication in the math palette. Well, we'll do that. And then we're going to round to the nearest 10th. So we're going to round to 1 decimal place. That's what the nearest 10th is. So over here, we have this really long decimal. And let me copy this. We'll make it smaller. Make it bigger so we can see. Flatten. Okay. Here. Well. Right here, ignore this. 10 to the negative 3.6 equals 2.5, blah, 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 really long decimal. But if we're supposed to round to 1 decimal place, this is going to be 2.5. Well, I ought to say x equals 2.5. And then what you see is e to the negative 4. That's not the way the answer looks. So we're going to have to translate it. The e stands for times 10. And the negative 4, see, it's not written that way. I need to bring it down. E negative 4. All that means is times 10 to the negative 4 power. So your answer is going to be x equals 2.5 times 10 to the negative 4 power. And that, let me write it over here also, 2.5 times 10 to the negative 4 power. And that's the translation of scientific notation. Okay, so that's what you get. That's your answer. Let me put a blue box around it. Now we need to go back to not scientific notation. How you go back is you click the mode key. And you see the normal flashing? We want normal. So hit enter. And now we're back to normal. How cool is that? That's pretty cool. Okay, so, yeah, that's cool. So, second quit, and we'll be ready for the next problem. All right, now what is this next problem? The loudness of a sound. Very important. If a sound is too loud, it can hurt your eardrums. It can permanently destroy your hearing. That's what happened to me in the 60s. Woo-hoo-hoo! I danced right in front of the amplifier. Woo-hoo-hoo! Not the amplifier, the speakers. Woo-hoo-hoo! Yeah, I did. Now I can't hear a thing. Well, I can, but definitely damage. Lights would flash. Bah, 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 bah. Psychedelic posters. Memories. All right, we've got loudness. Loudness in decibels. That's how you measure loudness. And that's given by this formula, which is a lot like the earthquake formula, the Richter scale. L equals 10 times the log of I, where I bet that's the intensity, right? Just like before, over I naught. All right, let's read this. where I naught equals, oh, it's actually a number. Yuck. I naught equals 10 to the negative 12 W per meters squared. I don't know what the W is. You can find out. The intensity I of a sound is 4.1 times 10 to the negative 6 W per meter squared. How loud in decibels is this sound? Well, L is the number of decibels. So what we are going to do here is, if we're looking for L, all right, we'll have 10 times the log. I naught is 10 to the negative 12, and I is 4.1 times 10 to the negative 6. Well, here I thought I was going to get away with not using scientific notation, but just take care here. L equals 10 log. Now, remember the baby math you learned, okay? Remember the baby math you learned. We have like bases here. We did a quick review of this. See, A to the B over A to the C equals A to the B minus C. Our base is 10. So this is going to equal 4.1 times 10 to the negative 6 minus negative 12. So let's work this out before we do anything too exciting. L equals 10 log 4.1 times 10 to the negative 6 plus 12. Well, negative 6 plus 12 is positive 6. So L equals 10 log 4.1 times 10 to the 6th power. So now let's do that. Let's see what happens. I'm going to have 10, and I'm going to say times, even though I don't really need to. 10 times log 4.1 times 10 caret 6. Come down and close your parenthesis. For some of you, it might mean you end up with 2 parentheses. Okay. Ooh, this is exciting. Let's try it. That's the answer I get. Let's see how they want their answer. Woohoo! We did it. It says round to the nearest whole number as needed. All right. So L equals 66, and then there's a 0.1 and a bunch of decimals, but this 1 will not cause the 6 to round up to a 7, So L equals 66 decibels. And you can look that up on the internet and find out whether it's dangerous or not. So let's do this just for future reference. There it is. And we'll just make it fit. Hopefully. Right here. It's not as hard as it looks. But for this one, you do have to remember the basic exponent rules you learned in beginning algebra and then reviewed in intermediate algebra. Here, we did talk about them a couple of times. So time to relearn them because we're going to learn the arithmetic of logarithms. Logarithms have their own arithmetic system that's based on those basic rules of exponents that you started learning way back in beginning algebra. Long ago and far away, or not so long, not so far away. Like I said, we've already reviewed them a couple of times here. But this is totally different. Okay. Now here's the first rule, and this is why we need to spend more than one day. This is called the product rule. I wrote it over here. The product rule of logarithms. If you've got a log to any base, so that this includes log, which is log base 10, and ln, because ln is just log base e. E is a number that's about 2.7. So any log, this is going to be true for. And then we've got some examples. All right, so what am I saying here? I'm saying this. Suppose you have log base 3 of 4x. Just suppose. Well, that's going to equal log base 3 of 4 plus log base 3 of x. And it works the other way around as well. If you have log base b of a plus log base b of c, then that's going to equal log base b of a times c. So an example of that is, suppose you have the ln, because this is true for all logs. If you have the ln of 5 plus the ln of y, then that's going to equal the ln of 5y. So either way you do it. All right, now here are two of your homework problems. Log base 6 of 35 times 25. They don't want you to multiply the 35 times 25. What they want you to do is write this in this form using the product rule. So I'm going to do it for you. log base 6 of 35 plus log 6. 6, that's a 6. There you go. Log base 6 of 35 plus log base 6 of 25. And over here, the other way around is also true. Log base b, whatever that is, log base b of 2 plus log base b of 61 is going to equal log base b of 2 times 61. And depending on the instructions under the answer box, if it says simplify, if it says do not simplify, this is your answer. If it says simplify, then that's going to be log base 6 of 122. And that's using the product rule. We're going over this today in order to help you on Monday when we go over it all again. We're going to go over each of the homework problems and talk about which rule you're using. And then do them. Here, we're using the product rule there and here. Now we have the power rule. Log to any base of a number raised to a power is going to be that power, that exponent, brought down in front and multiplied by the log base b of the number. So these exponents are movable. If you have a problem like this with a number in front of the log base b of a, you can write it as log base b of a to the c, because that number multiplying the log becomes the exponent. And that's the power rule of logarithms. So here I've done a couple of homework problems for you. Here they give you this problem right here, and they say express it as a product. A product is two things multiplied together, two or more, I guess. So log base p of x to the negative 6 power. The way you make this into a product is you bring the negative 6 down front and let it multiply log base p of x. And if you start out with a number like this, I couldn't find one offhand, so except for that, I found that after I made up my own. Negative 3 times the ln of 4, if you're supposed to write it as a product, or if you need to write it as a product, then that would be the ln of 4 to the negative 3 power. Now here's a homework problem in which you use the power rule and the product rule together. So the first thing you do, I left out the first thing you do. Isn't that silly of me? So let me write it here. This is going to be log, well, let me read it first. 1/2 times the log of C plus 5 times the log of D. And here you don't see a base. That means the base is 10. Okay, 1/2. This is going to go up, this 1/2 is, and become the power on C. Oops. Timeout. Okay, back to work. C to the 1/2 power plus this 5 is going to go up and become the exponent on D. I don't know if you can see, let me make it bigger. Right there, 1/2 becomes the exponent on C, and 5 becomes the exponent on D. So this is going to be log of D to the 5th power. Okay, and really, or Mr. Stewart will get you. He was my high school college algebra teacher. We had little beginning college algebra in high school back in the old days. Yes, they taught Latin too. We were pretty well educated. Okay, now look what you've got. You've got the log of an argument plus the log of an argument. That plus means you're going to use the product rule. Here you use the power rule. Now you're going to use the product rule, log of C to the 1/2 times D to the 5th. And that would be your next step, which I have here. Now what you need to memorize, what you've learned in the past, and you probably slept till then, is that anything raised to the 1/2 power, any number raised to the 1/2 power is the square root of that number. So C to the 1/2 power is the square root of C. Meanwhile, times D to the 5th. Now, custom, perhaps, says that we move what's not under the radical to the front of the radical. So this is going to be the log of D to the 5th times the square root of C. So, you have lots of opportunity to practice this stuff, which is another reason we're spending 2 days on it. Definitely need to get flashcards. Okay, now we have the quotient rule of logarithms. The quotient rule. Quotient means you're dividing. And here, if you have a log to any base of a number over a number, or a variable over a variable, that becomes a subtraction problem. log base b of a minus log base b of c. So if you have log base b of a over c, that's log base b of a minus log base b of c. Now here's a homework problem for you. Express the ln of v over n as a difference of logarithms. Difference in mathematics means subtract. The ln of v over n is going to be the ln of v minus the ln of n. Piece of cake. And the other way around. If you have it the other way around, like log base b, that log base b just means log to any base. Log base b of x minus log base b of y. Well, you use the quotient rule. That's going to be log base b of x over y. See how much more compact it is when it's written like this. Okay, before I do anything else, I want to show you where all this stuff comes from. Logarithms, you need to use your imagination. Let me go to another page. Here. Suppose you have 3 to the second power and 5 to the fourth power. Notice you've got two different levels of numbers here. You have the base numbers down on the bottom, and there's another level of numbers where the exponents are. Logarithms live up here. Logarithms are exponents. It's kind of like complex numbers live in the complex number system. Well, logarithms live in the logarithm number system. And that's the exponent number system. And they have a different arithmetic that you already know, and we're going to go over it now. Suppose I have x to the third power. Well, I don't want to use any of these numbers because you could think they're related. They're not. X to the fourth power times x to the third power. We have a rule that says when the bases are alike, you add the exponents. And so that's going to be x to the seventh. If you want to imagine the exponents being alive, they know when they're added that on that lower level, multiplication is going on. So that's where we get the product rule. No. Here, the product rule. That's where we get that plus sign. Now, the quotient rule, right here, it should be pretty obvious right now. If you have b to the a power over b to the c power, then you're going to have b to the a minus c. Log base b of a minus log base b of c. Logarithms are the way they are because they actually live up here. Logs. My log's bigger than your log. My mom can beat up your mom. Same kind of thing. Especially if you have a vivid imagination. Now, what about this power rule? That's pretty ugly, at least in the beginning. Well, if there's a basic rule, as in beginning algebra, BA. Beginning algebra basic rule. If you have a base raised to a power, and then, doggone it, raised to a power again, you multiply the powers. Let me erase this so you don't get mixed up. This is related. Yeah, see how you bring the C down in front and now you've got multiplication. Just like this. This would be 2. Where's my thing? Getting all excited here. This would be 2 to the 3 times 4, which is 2 to the 12th power. So all of these things are like earthbound versions of what's happening up in the exponent level. So what's happening, if you can kind of, you see the value of having been raised without computers, before there were personal computers, is people used slide rules. You need to look up a slide rule on the internet. They're fascinating. There's a different level of physically, a different level on a slide rule for regular numbers and for exponents. So when you're working with logarithms, you're really physically jumping up to the logarithm level and you can actually see it. So it's not a strange idea to me at all. But now we have calculators, and all the magic happens inside the calculator. So you don't have first-hand knowledge of what I'm saying. But, so you've got to take my word for it. All right, let's finish up. I know this is probably culture shock for you. This is like, I can't handle it. Okay, whatever. Yeah, this is the last one for today. There are 18 problems in this homework set, and we're gonna do them all on Monday. We're gonna try to do them all, and I think we can. But you need to look over these. The best thing for you would be to actually go to the properties of logarithms and look through them. You don't have to do them, just look through them. All right, here we have the log of an argument minus the log of another argument. Arg. We'll call this ARGH. Arg, matey. All right. So when you have the log of arg minus the log of arg, this is what you get. You get arg over ARGH. It's just my vivid imagination again. But that's what you've got. You've got the log of x squared minus 2x minus 15 over x squared minus 9. That's what that minus means. So now, what do you do when you have that? You factor it and then you cancel. The numerator is x minus 5 times x plus 3. The denominator is x minus 3 times x plus 3. The x plus 3's cancel, and you're left with the log of x minus 5 over x minus 3. The quotient rule, actually putting it to use with something. So I should write quotient rule here. Okay, so what we did is we finished up in your homework Introduction to Logarithms, Part 2. Four word problems. And then we spent the rest of our time getting used to the idea that logarithms have their own number system. And you're going to have to learn a new kind of arithmetic. And we're going to be using it for the rest of the semester, what little of it there is left.